Hello everyone, we have done a major project named Ternary Subtractor where we have designed both accurate and approximate subtractor. So for the designing of those accurate and approximate subtractor, first we need to know about, we need to have some basic knowledge of binary and ternary. So in binary logic we can see that it has two logic levels, 0 and 1, where 0 indicates ground and 1 indicates VDD. And in the same way in ternary logic we can see 0, 1, 2 are the three logical levels where 0 indicates ground, 1 indicates VDD by 2 and 2 indicates VDD. So we can have a doubt that why ternary when there is binary. So in ternary logic, as there are three logical levels, we can have many logical operations when compared to the binary. So we use ternary when compared with the binary. We have even learned the representation of decimal numbers in binary form, so that the same logic was can be extended for the ternary logic representation. And even we have learned how a decimal negative number can be represented in ternary, because the subtractor can even have a negative difference output. And we have learned about many like gates. Here I have just shown binary like OR gate, but we have learned other gates like and nor, etc. We can see that in binary OR gate, output is the maximum of the inputs given. So the same logic was extended for the designing of ternary OR gate, where output is the maximum of the inputs given A and B. And this is the binary half subtractor, and the same logic was extended for the design of ternary half subtractor, and this was extended for the design of ternary full subtractor. And this ternary half and full subtractor was used for n-bit subtraction. Here I have just shown the 4-bit subtraction, but we can have n-bit subtraction. And we have learned many different papers of subtractor, where we have seen subtractors were designed using decoders, mugs, and transistors. This was the first circuit of subtractor, where a subtractor was designed using decoders and ternary gates. And in the second circuit, the ternary gates were replaced with binary gates, so that circuit hardware gets reduced. And here we have used AOL logic, and the fourth circuit is used using decoders and NAND gates. And this was designed using 3:1 mux, and this is designed using 3:1 and 2:1 mux, and the 2:1 mux. We can see that from decoder based to the 2:1 mux based, the power consumption and propagation delay was reduced. And this was the methodology which we have used for the designing of our project approximate and accurate subtractors. And the next one, in the next one, they have even used the clock. This was the accurate subtractor truth table of our project, where A and AP are the negative and positive outputs of A, and B and BP are the negative and positive outputs of B, and X1 and X2 are the intermediate outputs of the borrow and difference outputs. And here we can see that the ternary inputs of A and B were converted only in terms of binary, where we can see A and AP, B and BP values were only in play in terms of 0 and 2, where by that we can say that 0, 1, 2 inputs were converted to the only in terms of zeros and 2s. So why approximation, and what is approximation? Approximation is nothing but including an error at particular position, so that the hardware equations get reduced, so that hardware circuitry gets reduced, but with a minimal error at the output. So this was the accurate x1 and x2 equations, where like in the previous truth table, the x1 values were taken and it was put into the k maps, so that we can get the x1 equation, and in the same way we can even get the x2 equation. So these are the x1 and x2 equations of accurate subtractors. So using these equations we have designed a circuit using C and FITs, and the x1 block was designed separately, and x2 block was designed separately, and those outputs were given to the encoder to get the reference output. So that was the part of accurate subtraction design. And now for the designing of approximate subtractors, we need to include some errors. So we have we have done different cases where we included errors of x1 and like we have included errors in x1 k map and even in x2 k map at different position, and like number of errors were even like different. Here we have included one error at position 2220 and have got one equation, and in the same x1 k map we have included an error at 0022 position of only one error, but here we have included two errors. We can see that x1 equation was reduced. In the same way we have done for x2 equations, and using those equations we have got different cases. Like case one, for all those x1 and x2 cases, like cases we have designed circuit and truth table, and even we have done the error graph. So after doing all that cases, like we have done a MATLAB simulation of these all these cases, and we have got a median, a median error rate. So we can see that error rate of case 4 and MED and NMED values were better when compared with the other cases. So we are taking the case 4 as our approximate subtractor. This was the approximate subtractor which we have designed, and so though that was the approximate half subtractor. So for the designing of full subtractor, we have used two approximate half subtractors and half sum block, where like first input A and B were first given to the one approximate half subtractor, and the difference output was again given to the again another approximate half subtractor with the other input C, so that we get the difference final difference output, and the bar of first half subtractor and the second half subtractor were added to get the um, final bar output. So that approximate half subtractor and full subtractor was used for the 8-bit subtraction. So this further this 8-bit subtraction was used in media applications, like where we have taken two input images, input image 1 and input image 2, and input image 2 was subtracted from the input image 1. These are the outputs we have got, and we can observe that image 1 and image 2 outputs, like output image 1 was got using accurate subtraction, and image 2 was got using approximate subtraction. So we can see that both were similar. By this we can say that our approximation was proper. This was the PSNR and SSIM values of our background subtraction, and these were the simulation results of our accurate and approximate half subtractor and full subtractors. And we have even included like how much percentage of advantage we have got when compared with the 2:1 and 3:1 marks. Thank you.